Hello and welcome to Tech of the Day. Today we are going to talk about developing solutions that use Microsoft Azure Blob Storage, and this series is related to AZ-203 or AZ-204 Azure Developer Certificate Associate Certificate. In this module we will cover Microsoft Azure Blob Storage security, working with Azure Blob Storage, and in the end a lab constructing a polyglot data solution. So if you are interested in learning more about Azure Blob Storage, please stay tuned and hope you like it. Let's go. We already discussed what we're going to do. Lesson 1, Azure Blob Storage. In this lesson, we will talk about Azure Blob Storage, blob hierarchy, storage tiers, blob types, block blobs, append blob, page blobs, blob event, shared access signature, SASs, stored access policy. Very interesting topic, very interesting topics actually, and I hope you will like it. Access blob storage. Azure Blob Storage is Microsoft Object Storage solution for the cloud. Blob storage is optimized for storing massive amounts of unstructured data. Unstructured data is the data that does not adhere to a particular data model or definition, such as text or binary data. User or client applications can access objects in blob storage via HTTP or HTTPS from anywhere in the world. Objects in blob storage are accessible via Azure Storage Representational State Transfer REST APIs, Azure PowerShell, Azure CLI, or Azure Storage Client Library. So you can access blob storage using REST APIs, Azure PowerShell, Azure CLI, or an Azure Storage Client Library, which you can use directly in your projects. Client libraries are available for a variety of languages including .NET, Java, Node.js, Python, Go PHP, and Ruby. So very easy solution, very good solution for your storage purpose and different type of data which you don't want to put in your app service or virtual machine or wherever. Let's say you have big images which you don't want to put in your virtual machine because you need some space for that, and it's cheaper, so you can use blob storage which is accessible via any means of transport or access. Let's go. So Azure Blob Storage hierarchy. Azure Blob Storage allows access to stored data through its resources. Azure Blob Storage contains many three components actually, like storage account. This refers to an account that you can use to access Azure storage. In terms of hierarchy, it's the parent account of the container and blobs resources. Container, this refers to a collection of objects that are grouped together and accessed by using the same base uniform resource identifiers, URIs. Blob, this refers to an object, typically a media file or disk, that is stored in the container. So you have three types of components in Azure storage. First one is you need to have a storage account which can contain containers, which can be image or video, whatever. And then blob. Blob is the media. So header.jpg and advertisement.png is in images, and intro.mp4 is in video. So I'll explain you later on. I will give you a practical hands on it in Azure portal. And storage tiers. Azure Storage offers different storage tiers which allows you to store blob object data in the most cost efficient effective manner. The available tiers include hot storage, which is optimized for storing data that is accessed frequently, cool storage, which is optimized for storing data that is infrequently accessed and stored for at least 30 days. Archive storage is optimized for storing data that is rarely accessed and stored for at least 180 days with flexible latency requirements. Because if you have big data that you don't really use often, let's say you use every 6 months, 5 months, then you can put it in archive and use it. If you have data which you use like say monthly, then you can put it in cool. If you have data which you use everyday basis, then you can put it in hot. Of course, the price changes. So storage tiers allow you to tune performance and cost to ratio that is ideal for your solution. So if you have hot, which is the most expensive one, and then you have cool, which is medium, and archive, the least expensive. Blob types. Azure Storage supports three types of blob, block, append, and page. Each blob type is designed to handle specific types of objects in storage. For example, block blobs are ideal for media files, append blobs are suitable for log files, and page blobs almost directly emulate storage disks. So let's talk about them more in detail. Block blobs. Block blobs let you upload large blobs efficiently. Block blobs comprise blocks of data. Each block is identified by block ID. You create or modify a blob by writing a set of blocks and committing them by their block IDs. A block blob can include up to 50,000 blocks. Each block can be different size, up to maximum of 100 megabytes, 4 MB of requests using REST version before 2016, and the maximum size of block blob is therefore slightly more than 4.75 terabyte or 100 multiplied by 50 blocks, a lot. So for REST version before 2016, the maximum size of block blob is little more than 195 gigabyte or 4 MB multiplied by 50 blocks. If you are writing a block blob that is no more than 256 or 64 MB for requests using REST version before 2016 in size, you can upload the entire block blob with a single write operation. You see the effectiveness of this. So you can directly write if it's not more than 256 MB, you can directly upload it. And the basic thing is a single blob can include up to 50,000 blocks. Ideal for data that is stored in blocks up to 100 mega chunks. Simultaneous upload of large blobs with a single write operation. Append blob. Append blob. Let's examine the characteristics of append blob. An append blob comprise blocks and is optimized for append operations. When you modify an append blob, blocks are added to the end of the blob only through the append blob operation. Updating or deleting existing blocks isn't supported. Unlike a block blob, an append blob doesn't expose its block IDs. Each block in an append blob can be different size up to maximum of 4 MB, and append blob can include up to 50,000 blocks. The maximum size of an append blob is therefore slightly more than 195 gigabyte. Append blobs are optimized for scenarios where data is added to the end of the contents of an existing blob. This makes Append blob the most performant choice for many logging solutions where text is added to the end of the log. And then there is page blob. Page blobs are a collection of 512 byte space that are optimized for random read and write operations. They are like hard disk storage and are ideal for virtual hard disks. To create page blobs, you initialize the page blob and specify the maximum size of the page will grow. To add or update the contents of the page blob, you write a page or pages by specifying an offset and a range that aligns to the 512 bytes page boundaries. A write to page blob can overwrite just one page, some pages, or up to 4 MB of the page blob. Write to page blobs happen in place and are immediately committed to blobs. The maximum size of page blob is 8 terabyte. So content to be added within 512 byte page boundaries. Write page blobs commit immediately. Ideal for virtual hard disks. Page created by initializing the page blob by and specifying the size. So blob events. Azure Storage events allow applications to react to the creation and deletion of the blobs, and using modern serverless architecture, it does so without the need for complicated code or expensive and efficient polling services. Instead, events are pushed through Azure Event Grid to the subscribers such as Azure Function, Azure Logic Apps, or even to your own custom HTTP listener, and you only pay for what you use. So that's really interesting topic in within Azure events, within Azure storage. So you have a blob storage of any type in a resource group, and you say if you put any file into this blob storage, I want to trigger an event which can be any handler. It can be Azure Functions, Logic Apps, Azure Automation Jobs, webhooks. So really handy. So common blob storage event scenario include image or video processing. Let's say you uploaded an image and you need to generate a thumbnail out of this image, or a smaller image out of this image to use in your website or wherever. You can trigger an Azure function which just resize your image, and it can be done automatically. So once one of your user uploads an image, it will be automatically translated or transformed, sorry, to any smaller or whatever size you want. So that's automation and good one. Search, indexing, or file oriented workflow. Asynchronous file uploads are good fit for events when changes are infrequent but your scenarios requires immediate responsiveness. Event-based architecture can be especially efficient. Now, third lesson is blob storage security. So one of the specific to blob storage term is SASs token generation from a shared access policy. We will talk about it. Shared access signature, SASs. Shared access signature is a URI that grants restricted access rights to containers, binary large objects, queues, and tables for a specific time interval. By providing a client with a shared access signature, you can enable them to access resources in your storage account without sharing your account key with them. So you can just give them an URI which contains a key, but but for a specific time to that specific user, and then it can expire. The shared access signature key query parameter incorporates all the information necessary to grant controlled access to the storage resource. The URI query parameters specify the time interval over which the shared access signature is valid, the permissions that it grants, the resource that is to be made available, and the signature that the storage service should use to authenticate the request. Valid key pattern by using shared access signature. A common scenario where an SASs is useful is service where users read and write their own data to your storage account. In a scenario where a storage account stores user data, there are two types of typical patterns: client upload and download data via front-end proxy service, which performs authentication. This front-end proxy service has the advantage of allowing the validation of business rules, but for large amounts of data or high volume transactions, creating a service that can scale to match demand might be expensive or difficult. Using the valet key pattern, a lightweight service authenticates the client as needed and then generates SASs. After the client receives the SASs, they can access storage account resources directly with the permission defined by SAS and for the interval allowed by the SAS. The SAS mitigates the need for routing all data through the front-end proxy service. So the client application authenticate and get the SAS, and then after you get the SAS, you can then directly read the data and write the data. Stored access policy. The shared access signature can take one of the two form: an ad hoc SAS. When you create an ad hoc SAS, the start time, expiration time, and permissions for the SAS are all specified on the SAS URI or implied in the case where the start time is omitted. The type of SAS can be created on a container, blob, table, or queue. And then second type is a SAS with a stored access policy. Stored access policy is defined on a resource container, a blob container, table, or queue, and can be used to manage constraints for one or more shared access signatures. You can simply say this is my policy which contains this permissions, and then I add this permission, add this policy to my SAS token. SAS token generation from a stored access policy. When you associate a SAS with a stored access policy, the SAS inherits the constraints, the start time, expiration time, and permissions that were defined for the stored access policy. The difference between ad hoc SAS and stored access policy is important for one key scenario: revocation. And SAS is a URL, so anyone who obtains the SAS can use it regardless of who requested it to begin with. If an SAS is published publicly, it can be used by anyone in the world. Stored access policy give you the option to revoke permissions without having to regenerate the storage account key. Set the expiration on these to very long time in future or infinite, and make sure it's regularly updated to move it further into future. Working with Azure Blob Storage. In this lesson, we will cover managing blob properties and metadata, manipulating blob containers using blob container property using .NET, manipulating blob container metadata in .NET, Lease blob operations, and AZ copy. Managing blob properties and metadata. Containers and blobs support custom metadata represented as HTTP headers. Metadata headers can be set on request that creates a new container or blob resource, or on a request that explicitly creates a property on an existing resource. Metadata headers are name value pairs. The format for the header is XMS meta name string value. Beginning with version since 2009, metadata names must adhere to the naming rules for C# identifiers. Names are case sensitive. Note that metadata names preserve the case with which they were created, but are case sensitive when set or read. If two or more metadata headers with the same name are submitted for a resource, the blob service returns status code 400 bad request. Metadata consists of name value pairs. The total size of the metadata pairs can be up to 8 kilobytes in size. Metadata name value pairs are valid HTTP headers, and so they adhere to all restrictions governing HTTP headers. Metadata on a blob container resource can be retrieved or set directly without returning or altering the content of the resource. Note that metadata values can only be read or written in full. Partial updates are not supported. Setting metadata on a resource overrides any existing metadata values for that resource. So, and then blob container properties. Containers and blobs are also Container and blobs also support certain standard HTTP properties. Properties and metadata both are represented as standard HTTP headers. The difference between them is in the naming of the headers. Metadata headers are named with the header prefix XMS meta, and custom name property headers are standard HTTP headers names as specified in the header field definition HTTP protocol 1.1. The standard HTTP headers supported on containers are etag last modified, and standard HTTP headers supported on blobs are etag last modified, content length, content type, content MD5, content encoding, content language, cache control, origin, and range. So you understand the difference between metadata and properties. Now, manipulating blob container properties in .NET. The cloud storage account class. Cloud storage account class contain create cloud blob client method that gives you programmatic access to client that manages your file share. To reference a specific blob container, you can use get container reference method of the cloud blob client class. After you have a reference to the container, you can ensure that the container exists. This will create a container if it does not already exist in the Azure Storage account. With a hydrated reference, you can perform actions such as fetching the properties metadata of the container by using fetch attribute async method of the cloud blob containers class. After the method is invoked, the local variable is hydrated with values for various container metadata. This metadata can be accessed by using the properties method of the cloud blob container class, which is of the type blob container properties. So if you understand here, you see we created a cloud blob client first, and cloud blob client is coming. We can create cloud blob client using the cloud storage account class. And once we have the client, now we want to get the reference to this container image. Images is the name of the container, and if it does not exist, it will create this. If it does exist, then you will get the reference to it like this. And then you fetch attributes from this container, and then you say container.properties all star. Easy. Now manipulating blob container metadata in .NET. Using the existing cloud blob container variable named container, you can set and retrieve custom metadata for the container instance. This metadata is headed when you call fetch attributes or fetch attributes async method on a blob or container to populate metadata collection. This code example sets metadata on a container, and in this example we use the collections add method to set metadata values. And the same thing we will do in the next metadata. In the next example, we will set the metadata value by using implicit key value syntax. To persist the newly set metadata, you must call set metadata async method on the cloud blob container, this one. So you see what we did. We created the client like same like before. We got the reference and we created if it does not exist. Then in the container metadata dot add doc type text documents container metadata category equals to guidance. So we added two types using two types. You see, we added like a collection and we added like a key value. And then you say set metadata async. To persist the newly set metadata, we called set metadata async. Demo. In this demo, managing Azure Blob Storage by using .NET. In this demo, we will show how to use Azure Storage SDK for .NET to create and validate blobs and containers in Azure Storage. Manage the container by creating, downloading, listing, and deleting blobs using the Azure Storage SDK for .NET. So, this demo, we will do this demo in a specific lab because it needs some time to set up, and I want to show you from scratch every step how to manage Azure Blob Storage by using .NET, and I will do from scratch how to use Azure Storage SDK for .NET to create and validate blobs and containers in Azure Storage. So please watch my other videos. Next to this, I will add a reference to this video so that you can easily watch the lab if you want to. Otherwise, you can continue to the theoretical part, because I want to separate the lab and the theoretical part so that you can do whatever you want, because I know many people would only like to watch, let's say, theoretical part, or many would like to watch only the practical part. So that's why I want to separate them. Exclusive access for modifying a blob. The lease blob operation establishes a and manages a lock on a blob for write and delete operations. The lock duration can be from 15 to 60 seconds, or it can be infinite. After a lock is established on a blob, the owner of the lock has exclusive access to write or update the blob during that duration of the lease. All subsequent clients must wait to perform any updates on the blob until the owner of the locked blob completes the operation. And this is done to make sure that no one else modify your blob while you are using it, for simple reason, right? to maintain the atomicity. Lease blob operation. The lease blob operation can be called in 5 modes. First, acquire, which is to request a new lease, renew to renew an existing lease, change to change the ID of the existing lease, release to free the lease if it is no longer needed to, so that another client may immediately acquire a lease against the blob. Break to end the lease but ensure that another client cannot acquire a new lease until the current lease period has expired. So you see the difference between release and break. Release will let another client immediately acquire the new lease against the blob, but break will not allow the other client from acquiring the new lease. Azure copy. With Azure files, you can use Azure copy to copy blobs between storage accounts. So if you just want to copy from one storage account to another storage account, you can simply use Azure copy. You can download Azure by download. You can download blobs to your local computer. Alternatively, you can remove the /pattern option to download all the blobs from the container. Remember, blobs do not have a folder hierarchy. The entire path of the blob constitutes the name. Assuming you are running the download command in your local folder path and downloading a blob named v whatever, and the let's say folder/name of the file, the AZ-copy tool will hydrate the blob in the following path, which will add the C. So you see, and this source will add where is the folder, to this more client, to this path. abc.txt will be added to this. So pattern match on a star prefix. You can perform pattern matching before downloading blobs. In this example, all blobs beginning with the prefix A are downloaded. So if you want to download all the blobs matching this pattern, will be downloaded. Before going any further, let me just show you how practically on portal, so that your concepts will be clear. So to have a container or blob storage, you first need to have a storage account. So you search for this and you need to create a storage account. So let's create it. Create new AZ-203, whatever group name I gave, storage ACC. Okay, and now I need to give the name AZ-203 not available. Storage, I hope not available. Yes, Nitesh, I'm sure it's available. And the location North Europe. Performance, that's really interesting to know. Performance standard or premium. So standard storage account are backed by magnetic drives and provide the lowest cost per GB. They are best for applications that require bulk storage or where data is accessed infrequently. Premium storage accounts are backed by solid state drives and offer consistent low latency performance. They can only be used within Azure Virtual Machine disks and are best for input-output intensive applications like database. Additionally, virtual machines that use premium storage for all disks quality for a 99.9% SLA even when running outside of the availability set. So premiums use SSD, and standard are magnetic drives, which are good for bulk operations. So because these are cheaper. And read access geo redundant storage. Let me make it more bigger. So you have many types of redundancy. Locally redundant storage, which is within a data center. Then zone redundant storage, which is within a zone. So if one data center fails, then another data center will take over. If geo-redundant storage, which is a geographical region, and then read access geo-redundant storage, which means read access. So if one storage fails, your storage account will be packed or copied to another one, but you will have only read access to that. So you can copy all the data from there and copy to your you can back up from there actually. And same way GeoZone redundant storage GZRS and read access GeoZone redundant storage. So we go with the read access geo redundant storage. And access tiers we talked about, cool storage or hot storage. We don't have archive yet in this one. I wonder why. If I change this to, and this one does not even have that thing. And if I go with blob storage, accounts with selected kind replication and performance only support block and append blobs. Page blobs, file share, tables and queues will not be available. Okay, so I go with V2 and no warning. It's interesting to know. And now the access networking. I want public endpoint so that anyone can access with the security, of course, with a key. And here we go next. Mm, yeah, interesting to know. Secure transfer required, enabled. Azure files, the current combination of storage account kind, performance, replication and location does not support large file share. So not all your options are available if you select different options. Data lake generation, data lake storage generation 2, hierarchical namespace disabled. I don't want text, so I will just go, and now I can just review and create. Validation passed, and you see the information I selected, and now I can create. And my storage account is under process. So you see here, to have blob storage, table storage or queue storage, you first need a storage account. Same thing when we will do using Azure Cloud Shell or .NET, we will need to do the same thing. First we will need an account, and then we will need a container, and then we will need to add resource to that container. So let's go to the resource and let's explore what we have. Status primarily available, secondary available, North Europe, West Europe locations, because we geo redundant, so we said read access. So primarily available North Europe and secondary available was West Europe. It automatically decides to which geo redundant it want. And subscription ID is okay, containers, files and tables, queues. So you see a lot of things here. You see the performance of egress and ingress, latency, request breakdown. We don't have any request yet, so no data to show here. And one more thing, the one thing I was talking about demo, you can easily have using .NET. and it will give you access. It will simply tell you about Azure Storage, and you can have these libraries very easy. We will do this later on, but Azure Storage Client libraries for .NET offer a convenient interface for making calls to Azure Storage, and you can directly go to this one, or you can, if you want to learn more, you can go to this introduction to Azure Storage, but I don't think you need now. You can have some source code in on GitHub that you can use for your reference, and you will need Azure Storage Blob batch, blobs cryptography, blobs common. If you need data lake, then data lake, shares and queues, and really easy to use. You see, you have everything here. You have everything you need. So let's go back. Okay, now we are in our storage account. We have no activity, of course, not anything. What we can do, we can have access control. We can provide access control to our storage account using a role-based access control. I think you know it. It's really easy. You just click on add here, and it will show you what type of control, I mean access, you want to give, if it's owner or contributor, and then you can assign type of access, like how. So that can be Azure Active Directory or other means, and then you can select the email or user. Data transfer. So you see, you have options, different options. So let's say if you want to transfer 50 giga of data with a bandwidth of 100 Mbps and transfer frequency, let's say repeatedly, it will give you the options what you can do. Azure Copy, Azure Data Factory, Azure Storage Explorer, Azure Storage REST API using your .NET Core, and it is saying can be as low as 2 hours. Everyone is saying 2 hours, 2 hours. This is estimated time, 2 hours. And then you have Azure Data Box, can be low as 2 hours. Azure Data Box Gateway, even still 2 hours, and Azure File Sync 2 hours. So these are the options you might have for data transfer. And then events we talked about, we can add events to our Azure function, Azure storage, and these are the automated events. Let's say you added a blob, any media to your container, then you can trigger an event to do anything with this resource. Let's say you dropped Azure CSV file, and then you trigger an event to store that information in your database, or do some extraction, transformation and loading thing, ETL operations. So that's very easy, very convenient actually. Then you can explore your storage account, and you can do it via this interface. You have it says whatever you have. If I don't have anything here yet, so nothing to show and tables, but if you have anything, it will give display that here. But bear in mind it's in preview, so you don't have any SLA for that. Access keys, very important. So you have two access keys, and you see here, that's the key and that's the connection string. The connection string you can directly use in your .NET projects. That's same like connection string you have for SQL database or whatever. So that's the same connection string but with a different structure. It just say default endpoint protocol, HTTPS, account name this, account key this, and then endpoint suffix core blah blah blah. Geo replication, we said geo read access redundant. So you see here it can show you where is your primary and where is your secondary. You see, very convenient. You can have course. You can simply add course rules to your Azure storage. Encryption, you can have encryption of your Azure storage data. I don't know if you want to do that. Of course, access will be a bit late. Take longer. A shared access key signature, which we just talked about. So here you see grant restricted access rights to Azure storage resource. You can provide shared access signature to clients who should not be trusted with your storage account, but whom you wish to delegate access to certain storage account. So you want to give access to certain storage accounts, so but you don't want to give them some rights or to do some operations uh, with you don't want to provide them keys. So what you want to do, you can say, oh, allowed services, I only want to allow drop blobs, not any queue or table. And then serve as resource type, you want to say container, and then I will remove it. And then I say allowed permissions are only what I don't want to give them read permission, I don't want to give them delete permission, no list, add permission, create. So they can add, create, or write data, but they cannot read it because it might be some important data for other clients, which you don't want them, uh, which you don't want your uh, different clients to know. So you can select that option. Then you can say if you want to give HTTPS or both. I say both, okay, and then I can just simply generate SAS and connection string. And interesting thing is I can directly use this SAS token in my calls, or I can use like this. So I can say blob endpoints with this connection string, and in the end it will add the SAS token as well. You see this thing is added here. Simple, very simple, right? And also I can use it as a directly with blob service URL. You see like this, and perfect. I'm ready to go now. You see, but I said no service allowed, so it will be only accessed with connection string like this, right? So we're ready to go with next one, firewalls and virtual networks. I can add some firewall rules, same like other resources. So no special comment to that. Private endpoint connections, I can add private endpoints for my specific clients and give them specific rights. Advanced security, if I want to add some advanced security. One more thing is I can add static websites to my Azure storage. Very interesting. If your website does not require to do some bulk operations in your database or some other heavy calculations, then you can add your static websites, your HTML pages directly to your Azure storage, and it can be hosted here then, and you can use it, which is very convenient because it's really cheap. Logs we just talked about, you can add logs. Okay, containers. In the container, how to add a container, you can just say add container, and let's say images public access. I want to give Okay, I want to give there are three level of access: private access, no anonymous access, then the blob level anonymous read access, and then container level anonymous read access. I see container level, which is the bad one. I created the container. Now it's available, and now if I just go to this container, I have no data yet, but I can upload surely the data to this one. I can upload from my computer, and it has this data now. I can go to this data, and if I try to access this, I can access it because I gave access to it. So simple, right? And you see here, interesting thing: lease status unlocked, lease state available, lease duration nothing, copy status nothing, copy completion time nothing. Now you can generate SASs tokens for you and generate specific keys if you did not allow actually. And one more interesting thing is you can add allowed IP addresses in this key, which in this token, which will validate when someone tries to access your resource. So very interesting thing in Azure Storage, a lot of interesting things actually. Then you can also add Azure CDN to your Azure Storage, file share, tables and queues, which we already talked about. And you have metrics, advisor recommendations as you have in every resource, and resource health, connectivity hack, and new support requests. So that is a simple one you have in every uh, resource. So now it's clear. So let's continue. You see AZ copying blobs between containers. That means the container we just created and another container. Let's say I created a container images, and I create another container uh, copy thumbnails. So I want to copy from one container to another one. I can just use this, but if you have same account, then you just need to say source and destination, source key, destination key, and the pattern. Same way you can say AZ copy different account, then you say source, the source, and destination, this destination account, and the source key, destination key, because for the same account source key and destination key was the same, but for source different accounts you have different keys and the pattern. So asynchronous copy. By default, AZ copies data between two storage accounts asynchronously. Therefore, the copy operation runs in the background by using spare bandwidth capacity that has no SLAs in terms of how fast a blob copies, and AZ copy periodically checks the copy status until the operation completes or fails. The sync copy option ensures that the copy operation gets a consistent speed. Here you see the sync option, synchronous copy. So AZ performs a synchronous copy operation by first downloading the blobs to copy from the specified source to local memory and then uploading them to the blobs storage destination. So first you download in the local memory and then you upload them. It's not directly. AZ copy copying blobs to Azure file share. So using your knowledge of AZ copy to copy blobs and file share, you can use the same commands to copy between storage types. The only things you would need to change are the URIs used in the source and destination option. In this first example, we copy content from Azure FileShare to Blob. So you have source, which is a file, and second is a blob. So demo using AzCopy in the Cloud Shell. In this one, what we need to do is open Azure Cloud Shell, create two storage account using the Azure CLI, populate one of the storage account with the same sample blob, and use AzCopy to asynchronously copy the blob between accounts. I want to give you this assignment. I think you can do it easily without my help. So I will go here and I will just I want to show you how you can get the uh, Azure Cloud Shell. And now you create a storage. So you simply go to your portal, you click on the Azure PowerShell icon, and then sorry, Azure Cloud Shell, and then if you don't have any storage account created, it will create a storage account to run your commands. And you go simply here. It is um, preparing the environment for me, and once it's done, it will give you whatever you want to do. So now I want you to do actually you need to create two storage accounts using Azure CLI. So using this, and then populate one of the storage account with this with a sample blob, and then you need to copy from one blob, one storage account to another storage account. So simply by using AZ copy, you can do that. But I want you to do that because I have already shown you all the commands what you need to do, and it will be really good if you can do that. Let's go. And then there is this lab constructing a polyglot data solution. The thing is, so you have I will show you in the lab. The lab I will do with the .NET SDK. You have been assigned the task of updating your company's existing event registration system to use more than one data service in Microsoft Azure. Your company's goal is to leverage the best data service for each application component. After conducting thorough research, you decide to store event sign-up seeds in Azure Storage, event metadata in Azure SQL database, and event registration in Azure Cosmos DB. You will take the existing application code and rewrite it to connect to use these data services hosted in Azure. I will do this lab when I will do the SDK for Azure Storage, and I hope you will find that video. I will put the link um, in the suggested video, so you will have in the end suggested video, so you will directly go to that one. Okay, so to review this, what we did in this video, Azure, we talked about Azure Blob Storage, we talked about Blob Storage security, we talked about working with Azure Blob Storage. We did not do any lab constructing polyglot data solution. I will do it in a separate video. That's better if I do it in a separate video because you will be able to understand it better, and also I can differentiate between theoretical and practical hands-on Azure. So thank you for watching, and please like, share, and subscribe if you like this video. And if not, then please let me know in the comment sections what you did not like. I would really appreciate your feedback because I really need it. Thank you, and have a nice day. Stay safe from Corona. Bye.